Hey, what's up? My name's Ian. We're going to be going over Module 1.4, Playing with the Building Blocks of Calculus. We're going to be doing a piecewise defined function. One piece defined for x is less than 1 and the other for x is greater than or equal to 1. I chose my function to be expressed as follows: square root of 25 minus x squared and negative natural log of x minus 1 plus 2 for my two functions. To find the domain of the first one, we know that a square root has to be a positive number or 0 to be defined. So we can simplify that here into these two brackets. Once we get our brackets, we can go to our little handy dandy sign chart, plug in all of our possible values to see what our results will be, whether it will be a positive or negative number. When we multiply those two together, the only possible positive outcome for our function, which we know has to be positive, is x is greater than or equal to negative 5, or x is greater than or equal to, less than or equal to 5. And that can be expressed in interval notation here. And when you apply the initial condition of x is less than 1, that comes out to this. Moving on to our second function of negative natural log times x minus 1 plus 2. Focusing on our natural log, we know that natural logs have to be a positive number in order to be defined. So we can simplify that here and then here. X is greater than 1, which is expressed like this in interval notation. And then you combine the two here. For our range, starting with our first one of 25 minus x squared, with our domain of negative 5 to 1, we'll plug negative 5 in, we'll plug 1 in, we'll plug 0 into our function set. That comes out as 0, 5, and square root of 24. So we know our minimum value, we know our maximum value, expressed in interval notation here. For our secondary function, we're going to focus in on that natural log again. Know that x has got to be greater than 1 for our domain. So we'll plug in x is greater than 1 into our function, and that comes out to be infinity, some infinite positive number. And we'll plug in any other greater number than 1 into our equation, and it'll come out negative or positive, one of those two. And that's expressed here, negative infinity to infinity, all real numbers. And when you combine those two, because they're overlapping, this is the interval notation expression. Plugging that equation into Desmos per the instructions looks like this, and gives us a cool little graph that kind of looks like a wave if you squint at it the right way. You notice the first function goes from 0 to 1, from negative 5 to 1, as we found out here. And our secondary function goes somewhere close to 1 but never actually touches it forever, and all the way out to infinity. Just continues on the lower, expressed here. And then for our ranges, we know that our first function's lowest range is 0 and our highest is 5. And for our natural log, both sides are undefined or approaching infinity, as you can see. And that's it, Module 1.4. Thanks for listening.